All right, hello everyone. Looks like we're ready to start. So I think that we'll do a brief introduction round and then we'll go into presentations from each of the presenters here. I'll introduce myself. I'm Melissa Kops. I am the architect for the City of New Haven. I also teach a course on green buildings at the Yale School of the Environment. And I sit as the municipal representative of the State Energy Efficiency Board. And I'm happy to have a talk on embodied carbon in concrete today. Latest figures apparently are that cement actually makes up 8% of global greenhouse gas emissions, which is a very sizable chunk. And we'll talk about some technologies that'll mitigate those emissions. So I'm just going to pass around the mic and have these wonderful folks introduce themselves.
Hi, everyone. I'm Becky Gallagher. I'm Sublime Systems Head of Project Development and Strategic Sourcing. Sublime, well, I'll get into it, but basically we make an ultra-low carbon cement out of Somerville, Massachusetts.
Hi, everyone. Thank you for having us today. My name is Chris Cotulio. I'm the Materials Sustainability Specialist for ONG Industries. We are a ready-mix supplier based in Connecticut, ready-mix concrete, and we're utilizing Positive, which obviously we'll get into, as a ground glass pozzolan to replace up to 50% of the heavily emitting cement, as Melissa said, in our concrete to greatly reduce our carbon emissions. I have a background in civil engineering. I have a master's, and my thesis was on ultra-high performance concrete. We actually used Positive in that concrete to achieve 24,000 PSI ultra-high performance concrete with a 25% replacement of the cement in that mix. So it really is an incredible material across all concrete applications. Really looking forward to the talk today. With that, I'll give it to TJ.
For context, normally concrete is 3,000 PSI, 24,000. Yeah. So that's pounds per square inch. And it's just the level of strength of the concrete. So 24,000 is quite strong.
Thank you.
Good morning. TJ Oneglia, Vice President of Construction Materials at ONG Industries. We partnered with Urban Mining to create the first ever plant to make the ground glass pozzolan with glass sourced from Connecticut's single stream recycling program. And we can't wait to tell you all about it. Nice to meet you.
And also I want to plug that Build Green CT, which is the local organization that deals with green buildings in Connecticut, is giving a tour of their plant in Beacon Falls on November 8th from 4 to 6 p.m. So if you go to buildgreenct.org, you can sign up for that tour. So let's start with the slide deck. Oh, we're starting with Positive then.
Sure. All right, so yeah, as TJ mentioned, we take post-consumer recycled glass from Connecticut, also some in Massachusetts, some in New York, several counties across the tri-state area. So the ongoing glass challenge in this country, I didn't realize till I started working in this role, you think you're doing the right thing by putting your glass in the bin. Unfortunately, 2/3 of the 12 million tons of glass that enters the recycling stream in this country doesn't get further repurposed. It goes to a landfill, unfortunately. So Positive gives that glass a home as a cement replacement in concrete. Almost all of the glass in the Northeast, in addition to the 2/3, almost all the Northeast glass gets landfilled. There are no bottle, manufacturing facilities in the Northeast region, and so most of that glass gets landfilled. The opportunity with Positive is that we're lowering societal operational costs by further repurposing that glass, instead of tipping it and sending it to a landfill in Ohio. So in addition to the carbon benefits, there's also societal financial benefits as well. So in a nutshell, this is basically what we do. I know we're crunched for time here, so I'll try and blow through these. Again, we take local post-consumer glass from the material recovery facilities in the tri-state area, transform that into Positive cement replacement, ground glass pozzolan. It gets batched into local concrete, local ready-mix producers, concrete unit masonry blocks, all sorts of concrete products, precast, pavers, and then reused again locally in sustainable construction, oftentimes without ever leaving a 100-mile radius. So it really is a true circular economy. I won't get into all the specifics, but this is just to show that positive is not an inert filler in the concrete. There is chemistry, there is a chemical reaction. The silica bonds with the calcium hydroxide, which would otherwise be porosity in your concrete, to create more strength, more calcium silicate hydrate. You can see the green circles there representing the strength crystals. And as Melissa talked about, there's a problem with cement, and that it accounts for 7 to 8% of global carbon emissions. That's really astounding for one material. If you look at a concrete cubic yard, only 10 to 15% by mass is cement, but that 10 to 15% of mass accounts for nearly 80% of the carbon emissions. So how you use your cement is really important, to use it responsibly and to replace as much of the Portland cement as you can to drastically reduce your greenhouse gas emissions. Just to compare positive to cement, this is a snapshot from our Type 3 Environmental Product Declaration. We produce 59.6 kilograms of CO2 equivalent per metric ton of positive produced. When you compare that to a typical Portland cement, it's 850 to 950 kilograms of CO2 per metric ton. So roughly a 95% reduction in CO2 on the high end of that GWP for cement. And again, we can replace up to 50% of that cement. So drastic carbon reduction when you think about we're only 5% of the carbon footprint of that cement. And so we have some projects going on at Yale that I wanted to highlight. Right now we're pouring concrete at the Yale Physical Science and Engineering building. These are some pictures I took last week. So that full circular economy, again, we take the glass from the material recovery facility from Yale campus, gets sent down to Beacon Falls, Connecticut, to either our Beacon Falls concrete plant or maybe our Bridgeport or Stamford plants, and then back to Yale campus. So without ever leaving a 50-mile radius, it's truly circular. Right now we've got over 500 yards with positive in it at a 30% cement replacement. That's equivalent to there's 102,000 pounds of positive used in those 500 yards. That's equivalent to roughly 205,000 glass bottles repurposed. So really astounding number. And 96,000 pounds or 48 tons of CO2 emissions has been saved by utilizing 30% replacement of the cement with positive. Also, Yale Peabody Museum a few years back, 600 cubic yards. This was a 15% replacement, a little lower. We had 60,000 pounds of positive used, which equates to over 120,000 glass bottles, roughly. 56,000 pounds or 28 tons of CO2 emissions prevented for this project right here on your campus as well. And I'd be remiss to show you what your rivals are doing. They told me their sustainability is better than yours, so you So, just kidding. So this is the Harvard Treehouse Conference Center, just to show a little bit of the performance as well. This is a 70% replacement in a ternary blend, 3 cementitious materials, cement, slag, and positive. So a really high replacement of your cement to reduce carbon. You could see the strength gains there over 90 days, really good strength. And just to show, it's only 160 kilograms of CO2 per cubic meter of that concrete. So really, and you could see on the right there, have the General Service Administration sets global warming potential limits. For a 5,000 PSI mix, the top 20 percentile is 305 kilograms for your GWP. We're roughly half that with this mix at Harvard. So just wanted to highlight some of the key projects going on into the universities in the area, and we hope to keep that trend going. So with that, I will hand it over to Becky. Thank you.
While this is being handed over, just for context, for those of you that don't know, concrete is made up of a few different things. It's cement, aggregate, water, anything else I'm missing? Sand and stone. Sand and stone. So the cement is the part that kind of like chemically binds everything together, and the cement has a very high global warming potential because of the process to make it.
So you have to heat a kiln to 2,500 degrees Fahrenheit. So the fossil fuels involved in that accounts for roughly 40% of the CO2 emissions for cement. So that really high temperature causes a lot of CO2 emissions. Also, so you take clay and ground limestone and put it in the kiln, and when you fire it to that temperature, a direct byproduct of that chemical reaction is CO2. I mean, they have a CO2 stack right off the kiln, and that's about 50% of the CO2 emissions associated with cement. So that's why it's so highly emitting.
Great, thanks. All right. No. Oh, question.
I just have a quick question. So is the positive process, does it eliminate that kiln process? It's both eliminating the carbon from the heating and the chemical reaction, or just the chemical reaction?
In the production of the soda lime glass, that's where that's taken place. And what we end up with is a amorphous silica that is pozzolanic in nature. So that CO2 in creating the glass has already been emitted. So what we're doing is saving that glass, keeping it out of the landfill. And our process is only involves really a low temperature dryer just to dry, residual moisture on the glass. And so it's a very low energy intensive process to clean the glass and then grind it into the powder particle size we need to be reactive.
And I'll just note, like, typically there have been historically, and they're called cementitious supplemental materials that replace the cement to reduce the embodied carbon. And typically that's been fly ash and slag. And fly ash is obviously the coal, it's from the coal industry, slag is from the steel industry. They both have some toxic qualities to them. So the idea of recycled glass is pretty cool because it's inert and non-toxic. One more question.
Does the positive mixture increase or decrease the carbon absorption of the cement, or does it stay the same?
Carbonation is pretty much the same. It will still capture CO2 from the environment. The more surface area of the concrete that's exposed, like oftentimes when they're demoing slab, they'll try and break it up into small pieces and leave it out to capture that CO2. But yeah, roughly the same carbonation.
Hey, Becky.
Yeah, first in case you can't hear, definitely a plug to visit Positive. I visited it and it's awesome. You should totally go. It's a great experience, and we aspire to reach that level of operation at Sublime.
Sure you will.
Okay, so Sublime, this is more of like a VC type of startup type of deck because we spend a lot of time pitching ourselves to potential funders. So it's a little bit less technical, and I'm also a little bit, a lot of it less technical because my background is more in business and renewable energy and project development and project finance. And so I'm more of the general purpose business person versus the scientific sort of technical engineering side. So I think it's a good compliment to have both of us here. Okay, so yes, we have big ambitions. We want to decarbonize cement, and whereas Positive is an additive to cement, Sublime's cement is a full drop-in replacement for ordinary Portland cement, or sometimes called OPC. Obligatory kiln shot. Yeah, it's extremely carbon intensive. Like Chris was saying, 50% from the kiln. You can't heat it with electric heat right now. And so if you go to a cement plant, you'll see these huge piles of coal just stacked up because it's the only thing, maybe with a little natural gas, that can take it to that temperature. And then because limestone has carbon inside of it, it decomposes into carbon dioxide. So it's a huge double whammy. But we continue to build as a world, as a country, and so we don't want to throttle that. We want to intercept it with better tech. We have a couple sort of differentiators versus other cement replacements. So we're fully carbon-free. We don't have carbon capture as a necessity. We don't need it because we're carbon-free from the start. CCUS or CCS is a big competitor, I guess, to Sublime in some ways, but we pride ourselves on not needing the sort of mop and bucket. We're sort of clean from the get-go, like Positive is. And at scale, right, driving down to costs that are competitive or lower than OPC. and scalable around the globe based on the feedstocks that we need to power the process. This is sort of an illustration of where we are different and then where we are the same. And the point of this slide is really show that Sublime cement is, for all intents and purposes, it looks the same, it feels the same, its workability is the same, all for those downstream folks. So we can use Boston Sand and Gravel, we can use the same ready mix trucks, we can appeal to the same developers, we can appeal to the whole value chain that is already built to accommodate OPC. Drop us in, tweak the admixture, we're going to be the same. Upstream is where we have the innovation and where we have the intervention. And so instead of a kiln, we have an electrolyzer, and instead of limestone, we use non-carbonate materials, so non-carbonate feedstocks, some of which ONG has at Southbury and that we've tested as well through our plant. We also aspire to use things like slag, recycled concrete through our process. It's fairly flexible. It can take in a lot of different types of stuff. Here it is sort of again, you have these feedstocks. This is our old pilot plant. We recently went from, I think it was 20 ton per year nameplate. Now we're at 250 tons per year nameplate in Somerville. I'll get to the scale up later, but goes through the sort of proprietary black box process and you get two intermediate products, lime and pozzolan, and you mix those together to make cement. Whereas OPC, you would have clinker, which is basically like a nodule that already has those two things together. We're sort of making them as separate products, and then we blend them together, and they have the same reactivity and chemical properties that OPC would have. And we have some cool co-products off of the side as well. And so, this downstream value chain thing is super important to us, not only getting like the ASTM certifications and sort of checking all the official boxes, but also working with the folks that spread the concrete, that pour the concrete, because you can hit as many, official standards as you want, but if the guys that do the spreading and the finishing of the concrete just don't like how it feels, that's a big problem because there aren't that many folks that do that out there. And if they just don't like how it feels, you're in trouble. So we've spent a lot of time from the get-go working with the whole downstream value chain to get them comfortable with how it feels and how it works and how it performs in the truck and all of these different things in sort of a ramping up of different types of pours to test our work. So we're not at the building level yet, but we're getting there. Yeah, and here's a little bit on the scale up. So we started at the bench in the lab. Leia, who's our founder with Yetming Chang, who's also like a serial entrepreneur from MIT, they founded this. They're battery scientists, actually, and they were looking for other applications of electrolysis, and they hit on concrete or cement. Yeah, so now our pilot is at 250 tons per year, and we are currently finalizing design and engineering for a 30,000 ton per year plant in Holyoke, Massachusetts, which is about 2 hours west of Boston. So that's the sort of valley of death in startup lexicon, because it's hard to, we still have a lot of risk in scale up, but we're not yet at the point where it would be a full-sized profitable plant. Most cement plants are 1 million to 4 or 5 million tons per year. And so this is this critical middle step for Sublime, and we've gotten funded $88 million from the US DOE last spring, and then starting to pull in some other folks as well. Oh yeah, now accepting capacity. Anyone want to buy some cement? Call me. Come by afterwards. And then a lot of the area where my focus is on the megaton plant, and so the full scale up, because it takes 4 or 5 years to develop a plant this large, and so you have to start now if you want to hit that when you're ready to hit it. And so to that end, we recently inked a partnership with 2 big cement majors, which you may or may not have ever heard of. If you're in this world, you probably have, but Holcim or Holcim Lafarge, and then also CRH, which owns Ashgrove Cement. So we have partnerships with both of them and working groups with both of them to co-develop this megaton plant. So that's a lot of where I'm living these days, but I also do some work on the Holyoke plant, like our community benefits plan and some of the federal permitting. Yeah, this is a bit outdated. So Siam Cement Group participated in our Series A almost 2 years ago, but now we also have Holcim and CRH on the strategic side, and we're probably doing a Series B. The rest of the Series B will probably be like Q1, Q2 of 2025, so hoping to flesh that out. And then US DOE has been super generous with us, both at the the lab and the pilot and the demonstration scale. And we're very, very ambitious. I think that's all. Yep.
Great, thanks. So I guess one question that we can start. Oh, actually, first of all, are there any questions from the audience? Oh, right.
Could you actually talk through a little bit of the CBP process for that project specifically, bringing in what stakeholder groups?
Yeah, the community benefits plan. Yeah, for sure. I'm glad you asked. Yeah, community benefits is super important. My background, my most recent background's in offshore wind, and so I'm used to like $40 million community benefits packages. And I came to Sublime, and we had to write one to apply for this grant. Also, it's just the right thing to do. Obviously, ours is a lot more modest than a $5 billion offshore wind plant would be, but it really matters to us to capture not only the generational benefits of carbon mitigation, but also the sort of here and now. And in Holyoke in particular, it's a dock track region, which is a disadvantaged community. And we know that the Biden administration wants at least 40% of the benefits of the project that's funded, so 40% of 88 million, needs to be captured by the Holyoke community or by dock tracks in general, even if they're not Holyoke in particular. Yeah, so there's 351 cities and towns in Massachusetts, and Holyoke is the poorest on a per capita basis. They have the highest concentration of Puerto Ricans outside of Puerto Rico, so it's really important to translate everything. They're 92nd percentile for asthma in the country, so that's pretty wild. So we need to be super careful about air emissions. Luckily, we really don't have that many. There's some dust that's really constrained to the site itself. So there's things that we need to do to satisfy DOE, and we need to check those boxes, and those are a little bit more formal. And then there's things that are also just the right thing to do, both from a business perspective and by the community. So I only have 2 direct reports. One of them is this guy, Pat Beaudry, and he's a 3rd-generation Holyoker, and about half of his job is just to be eyes and ears in the community. He volunteers every Friday. He tells me when we should sponsor events. He walks the site all the time. He manages a lot of our contacts with the mayor's office. We're in touch with like a lot of the grass tops leaders, I would say. So Nuestra Familia and Enlace de Familia are two big sort of Puerto Rican advocacy groups in the Holyoke community. And then another one that's really important to us is One Holyoke CDC, which is the Flats Community Benefit Corporation. The Flats is one of the poorer communities in Holyoke, and it's right across from our site. So this is this is the two-edged thing about federal grants. They want you to locate in the dock tracks, but that puts an extra burden on you to do the right thing. So, joblessness and educational attainment is very low in Holyoke. In fact, their schools are in receivership for poor performance. And so our CBP is twofold. One is openness to union labor. So we signed an agreement with the United Steelworkers for net neutrality, which means that we won't union bust and we will allow them on site, and we've hosted them both at the pilot and in Holyoke. That would be more for operational labor. We also signed MOUs with the Pioneer Valley Building Council and the Carpenters, which are separate, and that's very important, as I learned. Not to be confused. And then, so that's on labor, because enduring jobs is the most important thing to Holyoke and what we really can bring and what's in our core sort of ability to make change on. And then the other thing we did was an educational program with the Smithsonian Science Education Center. That's a smaller program, but meant to tackle sort of STEM education and find ways that are wanted and are asked for and are needed by the community to supplement some of the science education that they have going on at the high school level. I could go on. There's a lot of very cool stuff. We're trying our best to bring jobs to the Pioneer Valley. I myself just moved out to the Pioneer Valley. I'm really passionate about this stuff. There's a lot of good workforce, especially for operational labor. There's a plant to our north and a plant to our south, which are both unionized with United Steelworkers. So I can, that's certainly a possibility for our plant as well.
This is for the positive team. I'm curious if you could talk a little bit more about how you source the inputs. Are you going to waste facilities and buying their glass? How does that work?
Is it on?
Got to be 50% smarter than the gear you're working with. So we work directly with the municipal recovery facilities, which are private businesses that win contracts with municipalities to collect the single stream recycling and then sort the products that are in single stream recycling, make sure they go, if possible, to a recycler. So working directly with them, we're able to secure, in some cases, contracts. In other cases, just sort of handshake agreements to, for a certain number of loads a day, et cetera. But that's kind of how it's done, just sort of boots on the ground, knocking on doors and letting them know we're here. In Connecticut, the glass is mandated to be recycled, so that's part of the program, and that can happen as long as there's a home. So now that we exist, or we're in existence and are able to take the glass, it's beneficial for the municipal recovery facilities to send their glass to our facility. So that helps a lot as well, that it's part of the regulations.
Do you have an idea of the scale of the glass you're able to, versus the entire glass stream in Connecticut? What percentage can you convert into concrete?
In theory, I think the concrete market in Connecticut is large enough to consume all the glass that's in single stream recycling. There's just that much of it going on a daily basis, and it's all done it's measured in tons, literally. So there is, a capability there. What we've got to do is get the product out into the market, get people believing in it, and that's where institutions like Yale that, set goals and objectives for, their carbon footprint and how they're going to build their campuses, come into play. That owner-driven demand is really important for the success of all these products.
Great. I'm going to go to Brandon and then Anastasia.
I apologize if you said this already, but I think you mentioned 2/3 of glass ends up in the landfill. I guess how is that possible, even if we're putting them in the bins that we think are appropriate?
So unfortunately, because it's single stream recycling, it's easy for the end user, but it's more difficult for the material recovery facilities to sort. And like I said, there's no bottle manufacturers in the Northeast region. So most of our glass actually gets sent to Ohio to a landfill because Connecticut doesn't have a landfill. So it's things like that. Just it's easy again for the end user with single stream, but it's difficult to sort, process, find a home for it. There's no other home really in this region for recycled glass other than, to send it out of state for more bottle making or to a landfill, but Positive gives it a home right here from the state which it was derived.
Sure.
There's one other thing is that people tend to put stuff in the recycling bin that's not supposed to be in there. And the biggest problem with the glass is the porcelains and ceramics, coffee mugs and plates. And if you look at these bottles, you'll see the porcelains and the ceramics in there, and the chemistry of those materials works well for us. So you don't have to worry about removing that aspect of the waste stream.
Anastasia?
Yeah, hi. I'm so curious on both companies. The big scale-up plan. So most of the building in the world is going to happen not in the US or the Northeast, for that matter, but in other parts of the world. And, how do we take these sorts of technologies and make them available in other parts of the world? How ambitious can we get here? And with cement in particular, it's very, because it's so heavy and you have to move everything around with concrete and cement, it's very localized as to where those facilities are. And so I'm just wondering, can you tell more about your sort of scale-up plans? Maybe it's through partnerships with the existing cement companies, or just more about that, getting this technology out into the world.
Oh, sure. Yeah, we're really passionate about developing world applications. We have to walk before we can run, but labor can be a lot cheaper, materials can be a lot cheaper, permitting timelines can be a lot quicker. For example, you could have an ambition to permit a brand new quarry in a developing world, where in the developed world, basically forget about it. So developing world offers a lot of opportunities beyond just the decarb when it comes to speed and scale. And one company we look to sometimes is Lancetech, which pioneered in sustainable aviation fuel. And they were sort of forced to do their first demonstration plant in China. And they've done, I think, 10 demonstration plants subsequent to that first one. And many of them, I think almost all of them, have been in the developing world because they couldn't raise the capex needed to effectuate that in the developed world. So developing world holds a lot of promise. There's also a lot of, more political risk. There's language barriers, and just the practicality of the time zones and the travel, and also some concerns about IP. DOE has been pretty good with us. They're not clenching too tightly around the IP, but we do have some restrictions to be mindful of, especially now China, increased sort of care with that. And I also think, so we're learning more, but it feels like it's more distributed or like more local. Well, there's this interesting thing where developing world tends to have larger plants. Like in India, they're making them like 4 million tons per year, or just like get out of town. But also 80% or something crazy high like that of the cement industry in India is bagged cement, which is wild, because like that means like literally every pound of cement is coming out of the plant in a literal bag, because that's just how the industry works in a lot of developing countries. And so it's in that case, you may want to be a lot closer to the market. You may need to actually be inside of a city, versus having these smaller but more connected to a countrywide infrastructure like we have here, where you can have the luxury of having a more rural plant. From a permitting standpoint, that's a lot easier. And you have the benefit of ready-mix trucks coming in and out 24/7. Well, in the developing world, you may need to really cite a lot more carefully, because your stuff doesn't travel as far. But we have a lot to learn, and Wholesome and CRH are key to that. CRH is based in Dublin. Wholesome's even more international. They have a sort of weird colonial past with Lafarge and Africa in particular, and a lot of other developing countries. And so definitely looking to them to help be our shepherd, because we know, just like in Holyoke, you can't do it without a local person to guide you.
So to speak to the regionality, the idea is to keep that circular economy, right? So we want to open plants. Right now, we only have the plant in Beacon Falls. And I say we are partnered with Urban Mining CT as ONG Industries. But Urban Mining plans to open up different plants, across the country. They're looking at spots in Boston, New York, down in Maryland, I believe, or Virginia, close to the D.C. area, down in Florida, on the Pacific Northwest. There's a lot of interest. So the idea is to keep that circular economy. Where there are metro areas, there is glass, post-consumer glass to recycle. There's also a lot of construction going on in those areas. So the idea is to obviously to spread, as you're saying, and hopefully once we get enough traction, in our surrounding states and in the United States in general, that we can spread worldwide, and just we want to keep that circular local economy going. TJ, I don't know if you have anything to add.
Great. Oh, we did another question here.
My question was answered, but I'm from Ohio, so thanks for all your glass. My question was more on the local scale, is how you prime those markets to start using your product. But you guys covered it on that global and domestic side.
Great. And then we have a question in the back.
Yeah, I guess talking about the local economy, do you have any contracts with the state of Connecticut? How is that in terms of what are major impediments to use state-funded projects in a state?
So we're not in any contracts with the state of Connecticut as far as receiving the glass. That's done at the municipal level. As far as the state being a customer, we've gotten, if that's what you're asking, we're approved in their specifications. Like Connecticut DOT would be a large consumer of concrete in the state of Connecticut. So there's an ASTM standard for our product. Having that helps, and you submit the product to them, prove it out through time and testing, and they've been fairly open to the idea of using it. We went through a preliminary period, and now it's in their new specifications.
And in terms of cost, I'm just curious, what's the cost per pound of concrete, the traditional versus the...
No change in the cost of a cubic yard of concrete.
As of now.
Correct.
I'll bring up, since we're talking about cost, being a practitioner and working for a city that does a lot of concrete. One question I have is about suppliers and getting them the material. And what I've heard is that making space in yards for like a different material is an impediment. So I wonder if you can speak to that a little.
Sure, not all concrete plants are the same. Some are bigger than others, and there's a capacity issue when it comes to this stuff is stored. It's transported in bulk tankers and moved pneumatically into the plants, and so there's silos that contain cement and fly ash and slag and positive. And a certain concrete plant may only have 1 or 2 silos, maybe 3. So you're competing with that for that silo space with the ready mix producer. If they're using slag, they may be reluctant to give that up. Their mixes are all set and approved and tried and true. And there's a lot of inertia in this industry. It's hard to get people to change. So that's one of the obstacles that we have getting this into the market on a broad scale.
Okay, we have a question in the back over here.
It was answered, just the costs.
Great. Anastasia again.
Can you tell us more about how the new federal GSA push on embodied carbon is affecting you? Is that helping open up markets, or do you see like cities or states start to put procurement specifications that will help grow these markets? And if not, what can be done from the advocacy community to help build those markets in the state and city level?
Sure. So, yes, I showed that snapshot of the GSA table there. So for those that aren't familiar, the General Service Administration for federal projects that are funded through the Inflation Reduction Act, they set global warming potential limits for their low embodied carbon concrete. So each design strength of concrete from 2,500 to 7,000 PSI, pounds per square inch of strength, has a different global warming potential limit. As you increase in your strength, you need some more cement in the load, so that will drive your global warming potential up. But yes, we do find that it is driving the industry, not as much as we would like, but it certainly helps. There's a project in New York City right now at the Federal Plaza where they need, logistically speaking, they don't have a freight elevator that goes up to the roof, and I won't bore you with the details, but they need bag cement. They need a bag full blend concrete mix that meets those low embodied carbon concrete requirements set forth by the GSA. And they're having a really difficult time finding a supplier that has that bag material with that, GWP limit that will satisfy the GSA. So we're endeavoring to potentially, supply them materials in super sacks separately that they have to mix, up on the roof. So it does certainly help. It also, it produces challenges for the industry. Like we're saying here, there aren't any bag concrete suppliers right now that have what they need. So we're doing what we can to try to help them. So it drives the industry. It might not be a large enough project where, someone like Heidelberg, a large cement supplier will say, yeah, I'll give you a bag mix. I'll set aside, an entire silo for a supplemental cementitious material that we might not be using right now. So when the projects are big enough, it'll wake up the bigger folks out there. But yes, it does help. We're also working like the DAS, the Connecticut Department Administrative Services, so kind of like the GSA at the local level. They sent out a memo last March requiring the use of ground glass pozzolan whenever feasible. That's sort of a loose term, but they're endeavoring to work with Connecticut DEEP on revising their specifications for high performance building specs, like Connecticut's version of LEED. And so those do certainly help, but really we need owner-driven demand is a really big one. I do lunch and learns quite often to the architectural and engineering community to get them comfortable to use it in their project specifications. If it's included in the spec, at least we're brought to the table. But owner-driven demand, like that's why, you know, such as yourself at Yale and Harvard, like the leaders that want to push this sustainability movement forward, it's really important, you know, to have owner-driven demand and support from the owners because, you know, like in Harvard, we have to ship it up there. And so there is a logistical cost. In Connecticut, you know, we are cost neutral. But, you know, sometimes cash is king, unfortunately, if the owner's not willing to pay for it. It can be challenging. So I don't know. Do you want to?
Yeah, someone at Sublime has this saying, you can't push a string. You have to pull it. And that's where the owner-driven demand really comes in. So we're very passionate about these procurement standards. How much does the government buy? 80% of concrete or something?
I'm not sure.
Probably not that high.
Yeah.
Okay. All right, I'll retract that, but it's very, very high.
One question over here.
Sorry, Becky, you talked about the like mega scale. Is there a micro scale that would be applicable to precast concrete manufacturers?
Interesting. So like a full-scale commercial plant that's like significantly smaller than 1 million tons per year, but just makes precast?
Right.
Yeah, possibly. I mean, we've tested our applications a bit in precast, but not extensively because, again, partially because we're a startup and we're trying to attract the VC dollars. We go for the big disruption, and precast is seen as sort of a niche market. I mean, it's not niche, but it's more niche than disrupting OPC. And so in general, even with co-products, for example, you know, we've had interest in them, but we try not to get distracted. And so the focus is really on OPC and being a drop-in replacement for ready mix right now. And there's so much chemistry behind like the mix and the blend that is a little bit different for precast, which has a little bit different kind of standards and requirements that basically with limited resources, we're just like totally focused on that one thing, OPC replacement, until we fail basically. But the modular approach has definitely come up a number of times. You know, why does the megaton have to be 1 million tons per year? Could you do 100,000 tons per year? You know, could you do 50,000 tons per year? Is Holyoke potentially like a scalable, replicable size? So we have more techno-economic modeling to do on that and more to learn from the experience at Holyoke as to like what costs are fixed and what costs are variable in the experience of procuring and constructing that plant. But I think our strong hunch is that you probably have to go pretty big to enjoy those economies of scale and really get to cost parity. But it's not, that's not something that we feel like we know rock solid sort of in our bones. So there's a lot to learn there.
We got a couple more questions. Dan.
Hi. I guess question for both. Since concrete is so local, like you can only take it a half an hour, do you see any future in selling it as a carbon credit?
Oh yeah, we're definitely passionate about carbon credits, book and claim, exploring different types of systems that, just like energy, would separate the cement itself from the carbon attribute. And we just signed a deal with Microsoft, like an MOU, so it's not binding, but to kind of explore exactly this concept, because some of the biggest builders in the country right now are Amazon and Microsoft from data centers. So we spend a lot of time thinking about data centers with these Fortune 10s, call it, and what they need. And the data centers are, you know, they're not all happening in the same place time after time. Like my background in energy, it's like, well, you sign a 20-year power purchase agreement for a building that's going to last 20 years and just going to continue to consume energy the whole time. You can't sign. There's no forward contracts in this market. I was very sad to learn because no one can promise that you'll just build things every day, every year for 20 years. Like it's very cyclical. You're responsive to demand and all this stuff. And so you can't just build a plant in a particular area and expect that, like putting solar on your roof, like you'll just have a continuous offtake. And so separating where the cement is bought and sold from where the carbon attribute is realized, I think, is a really important concept in like this industry of building materials. And whereas for energy, it started that way, and now the standards are rising, and everyone wants it to be coincident and bundled and produced at the same time that it's consumed, and basically the standards for renewable energy credits and energy are going up to be closer and closer matched to the time and place of the consumption of the energy. I don't know that necessarily building materials needs to follow that same route. I think you can, if you can do it right with like the MRV, or management reporting verification, then you can maybe have a shot at having these things separated. Because unless you get really modular, you can't just chase around where these data centers and other buildings are going to be. You need to be able to fly those carbon attributes around the country and have a continuous, just regenerative sort of going concern type of operation at your plant, where you're off taking to all these different ready mixers and they don't care. It looks and feels like cement, whatever. Someone else is paying the premium and they're paying the $150 a ton that is the the price of OPC or whatever it is. So a lot to be done in this realm. I think certainly they're way, way behind compared to how far renewable and the energy market has come. But this is the area where we can make a huge amount of headway, whereas in energy, so much has already been done. The gains are a little bit more marginal. Here, the chance to make change and the chance to make an impact is really huge.
Yeah, it's a great question. So as part of that endeavor, we have Urban Mining has a Type 3 product-specific environmental product declaration for positive. At ONG, we also have the same Type 3 product-specific EPDs for all of our concrete mixes. So what that means is it's third-party verified, it's certified by NRMCA, the National Ready Mix Association. Ours are, I believe, positive is certified by ASTM. But well-known standard associations, and it's third-party verified. It's product-specific to our plant, to our product. So for slag and fly ash, for example, like the Slag Cement Association will take all of its members' global warming potential data, average them, and use an industry average environmental product declaration. So you can't get a true idea of, there's no transparency really with that. You can't get the true carbon offset. I'm sorry to plug your rivals again, but Harvard University did a case study with urban mining. It's called Harvard University and Urban Mining Industries Decarbonizing the Supply Chain. And they realized the value in that transparency of having a Type 3 product-specific EPD, because they foresee, and this is the Harvard Business School also, like you would think, why isn't the engineering department doing this? Every Harvard MBA student has to take this case study, because in Europe, carbon offsets are tradable, and they foresee that coming in the U.S. So we want to stay ahead of the curve and make sure that when that is a reality in the United States, that our EPDs are transparent and you can get a true carbon offset. So that's the idea behind the transparency in our environmental product declarations. Yeah.
The idea of slag, for instance, ground granulated blast furnace slag, which is a product we would compete against, most of that is imported into the United States. And so oftentimes they're not starting the carbon count until it's at the port of entry into the United States. So that fairness, that transparency, so that things are measured equally is very important, and getting to that level is critical. With our product, we have a beneficial use determination to receive the glass from Connecticut DEEP. It comes in by weight. We have to report how much we bring in. We clean it. We know how much waste we have going out by mass. When we sell it by the ton, so we know exactly how much glass went to the ready mix producer. It's batched by the pound into the mix. And so it's tracked, it's very transparent. There's a bill of lading at every step of the way, and you could take those weights through the EPD and turned it into the reduction in CO2 in the unit of sale of the cubic yard of concrete. So this product is really excellent when it comes to that level of transparency that you need to really be real when you're talking about carbon offset.
And we have one more question.
Question is actually for you, Melissa. Does the city of New Haven use any of these sustainable concrete materials? And if not, I guess what sort of barriers are you coming up against?
Well, I kind of touched on it before. We have thought about it, and we've definitely had presentations from the Beacon Falls, Pat Grasso, and the people over there. And we've thought about doing some test projects, and the issue that we come across is that we use local suppliers, and we're bidding a project to local suppliers, and even though it's supposed to be cost neutral, that sometimes we find that with local suppliers they have a little more trouble getting the product and implementing it. So we're still open to working with Positive to try to find a way to make it, or at least do a test project or make it part of our standard specifications. We have had slag as standard for low embodied carbon concrete in our specifications for many, many years. So switching from that is the hurdle for making something like this work at scale in New Haven. But definitely we're interested in it. It's just making it happen. Anybody have any other questions? I think we're at the end. We're at 10, so that was great. Thanks everybody, and we're here, and there's some really cool